Part 3 of section 21 is going to be an application problem. Example 21.5 gives us the formula capital A equals, and it says that this models the population of Texas, which is what capital A represents, in millions, T years after 2010. So anytime I'm given a formula in an application problem, I'm always looking to see what are the variables in that equation. And there are two, capital A and lowercase t. Remember that E does not count as a variable because E is Euler's number, which is the constant approximately 2.718. So there really are only two variables here. And once I know what the variables are, I need to make sure that I go back to the narrative and determine what those variables are meant to represent. Without that, I have really no chance of being able to answer any questions about the formula unless I know what those things mean. So let's look at part A. It says, what is the population of Texas in 2010? So when it says, what's the population, that means find a value of A. But we have to find A specifically when T is equal to something. It's not possible to find a value for A without being given a value of T to substitute into the equation. So if we're talking about in the year 2010, and T represents the years after 2010, then that means that there haven't been any years after 2010. If we're still in the year 2010, then no years have passed beyond 2010. So therefore, T would have to equal 0. So then the formula now says A equals 25.1 times E raised to the 0.0187 times 0. And that works out really well in the exponent. Since I'm just multiplying by 0, this is going to read 251 or 25.1 times E raised to the 0. And then E to the 0 is just going to end up being 1, so I'm just multiplying by 1, so all I have here is 25.1. But of course 25.1 is not the population of Texas in 2010. There's probably 25 people in each one of your classes when the semester starts. So we have to make sure that we realize that the narrative mentions that this is going to be in millions for this value. So we'll say the population of Texas in 2010 was approximately 25.1 million. And I say approximately because this is just a model. It doesn't give us an exact answer typically with a model. It's just there to give us an estimate. So that's part A. And for part B, it says, when will the population of Texas reach 29 million? So now it's asking us to find a value for T when capital A is equal to 29. So we don't have to put in, I know it says 29 million, but we don't have to put in all the extra zeros that go along with that because the model is already set up to work in millions. So 29 is what we need, which means that our formula is now going to read 29 equals 25.1 times E raised to the 0.0187 T. So I need to solve this for T, and I would treat this like any other solving problem back in the previous examples. The only difference here is that we had to set up the equation, and the equation just wasn't right out given to us. So the first thing I want to do is take care of this coefficient of 25.1. Dividing both sides by 25.1 is going to result in 29 over 25.1 equaling e raised to our exponent. In which case I now have an exponential statement with a coefficient of 1, and I can convert this into a log statement using the natural log because of this base being e. So this will be the natural log of 29 over 25.1. That's the argument for the log, and it's going to all be equal to the exponent, 0.0187t. In which case, to finish solving for t, divide both sides by the coefficient there for t. So we'll have the natural log of 29 over 25.1, all divided by 0.0187. And that is the exact answer for t, but that really doesn't do any good in terms of interpreting when the actual population of Texas will be 29 million. So you plug this into your calculator, get a decimal approximation, and I get about 7.7 years. So that means not quite 8 years, but certainly more than 7 years past 2010. So that would put us into 2017, not quite into the year 2018. So sometime during 2017, we would expect the population of Texas to reach 29 million. So that's exactly what we'll say. The population of Texas will reach 29 million in the year 2017.